About 2.5 years ago, we had a roundtable discussion on how we can get some plans to meet the needs of our community from an economic development standpoint as well as compliance. And we came up with a list of items, and one of them was the upgrade of the wastewater utility. One of the problems that we had was I&I in the system. We could not get the initial inflow below overflowing stage. With Commonwealth engineers, we developed a set of plans for developing of the utility. We secured federal, state, worked pretty diligently at getting some regional, local grant funds, and we put together a package that minimized impact to the customers with respect to not raising rates. We had a lot of secondary violations because of the high flows that would put us towards limits of non-compliance in respect to ammonia, TSS, sometimes BOD. And this upgrade was the construction of a 550,000 gallon EQ basin to take that initial inflow, store it, and then allow us to run the plant without process upset and maintain a level of treatment without overflows and illegal bypassing of the utility to the receiving stream. We feel that the EQ basin will definitely give us a long-term advantage. Plus it allows us to bypass individual units, and we can control the environments while we repair the units. Since substantial completion, we have had really no problems with maintaining heavy rains and operating the EQ basin, based on the fact that we have flexibility in our oxidation ditch and other units along with the EQ basin. The capacities have met expectations for the wet weather for the last 11 months. I've been here many a times, having to come in not knowing what your data, what your plant is doing. And after 20 years, I wanted the ability to see exactly all the data points in our plant: tank levels, flows, weather information on site. Person on call has a cell phone and is connected to all the auto dialers. And they also, we invested in an iPad. You can pull up the SCADA system wherever you're at as long as you have phone service. And we have a free viewer that we programmed in it that we can download to any device. We can observe what's going on in the plant in real time and in real weather situations. We know when to come in. We already know what to do. It was a good investment. It's a good tool. The hydraulics in both the waste-activated sludge pump station and the Influent pump station, the pumps were running right of the hydraulic curve, and there was so much turbulence because all the water was rushing in at high velocity that we were having recurring seal fails, cavitation, pump wear and tear, and that we spent a large amount of money. It was imperative to reduce the amount of turbulence through design and get the pumps to operate in a completely still environment and within the pump curves based on the elevations, head, friction loss, etc. And one of the ways that we did that is by installing some sectional walls that completely stop the velocity, and we make 2 compartments instead of 1. We feel that we're going to get many years of pump. Obviously pumps break, they need repaired, but based on how they're running now and the operation and the design, I feel that we're going to have a normal pump life instead of a yearly to 18-month having them repaired and then eventually replacing them after 2 or 3 years. Next to the hydraulic issues is the use of variable frequency drives on all the pumps and computerized controls that gives us more flexibility on how we run it. easy to change, integrates with the SCADA system. We can actually adjust speeds or settings remotely if we so desire. The major thing is the blowers, the aeration in all the systems, specifically the digesters, were 1972 products that we did not change out. They were basically running a couple hundred amps, but the peak on the demand was so high that our electrical costs were roughly around $4,000 a month. With the use of the VFDs, with the blowers that were installed, increased our efficiencies, and after a year I've noticed about a 25% reduction in power costs. When we put this project together, somewhere third, I think, on the list was to redesign our aerobic digesters. We basically had 3 tanks that performed as one unit and another tank that performed separately. And one of the things that I wanted to do is the ability to separate each tank by the use of valves so we could move sludge from one point to another through the tanks. We could separate them into batch processes, which would help my testing. And from a valving standpoint, whether it be cleaning the tanks, moving sludge to the stations for hauling, moving from tank to tank, or basically just keeping them separate. The design was very good in giving us flexibility. Another item that we included was to put in a bagger system. Commonwealth did this based on the fact that we had contingencies, and we put a design together that enabled us to have a backup. I would recommend Commonwealth engineers because of the fact that your follow-up is good. Your overall design, one of your strong points definitely is execution from design to substantial completion within budget. We did come in under bid, from projected costs to actual costs on our bid. We had some money left over. I've seen a lot of bad work that I wish they would have looked at a company such as Commonwealth. I give Commonwealth a good mark and look forward to a long relationship with them for years to come on all our infrastructure and planning.